Hi everyone, welcome back to our channel. Today we are going to do the experiment on verification of series RLC circuit. Okay, so coming to the resonance in series RLC circuit. So this is the circuit diagram. Okay, so here you are going to have three elements. So this is nothing but an R, L, C. So the value of R is 100 ohm, the value of L is 50 millihenry, the value of capacitance is 0.1 microfarad. These three elements are connected in series and we want to perform the series of these three connection and how the resonance is created. Whenever the resonance is created, automatically inductive reactance will be equal to capacitive reactance and only resistance will be left. Now we can see here from the signal generator you have to connect to resistance, output of the resistance you have to connect to inductor, output of the inductor you have to connect to capacitor, and you have to connect to an ammeter. Okay, and you can see here this voltmeter and this ammeter should be of rectifier type. Okay, so these are the equipment required for performing the experiment. This is an voltmeter rectifier type, this is an ammeter of rectifier type. To keep that 100 ohms, I have been selected an decade resistance box and I had kept it in the value of 1 ohm. Okay, so here we have to require 100 ohm. So you can see here this is of 0, adjusted it to get it as 100 ohm. And the next value, this is nothing but variable capacitance box, and here I require, as per the circuit diagram, 50 millihenry. So this is actually on 0. If you vary it to 10, 20, 30, 40, 50. Okay, so 50 millihenry is the inductance required. And coming to the, this is an variable capacitance. Here we require a capacitance of 0.1 microfarad. So this is the 0.1 microfarad. Actually this is 0, I adjusted to 1, therefore this is 0.1 microfarad. All remaining are in 0. Okay, so this is how we connect an decade capacitance box. Now let us try to see the connections. Okay, so very simple. So we have to connect R, L, C in series, and which has to flow through the ammeter and it has to return to the supply. So this is nothing but the signal generator or function generator, where we have amplitude adjustment as well as frequency variation. Initially set the type of signal as step type of signal. Okay, so and what is the procedure is saying also, if you understand, the procedure also is very simple. Just to give the connections as per the circuit diagram, and by using an oscillometer, just keep the output voltage to 5 volts. So how to keep it 5 volts, we will try to check it out. So connect the positive of the functional generator to the resistance input. Okay, and output of the, this is the output of the resistance box. Connect the output of the resistance box to inductance box. Connect the output of the inductance box to capacitance box, and output of the capacitance box to an ammeter. Okay, this is nothing but rectifier type. So this is an AC and this is of rectifier type, connected to positive. Okay, and the last terminal where we have, from this you directly return to the neutral. Okay, and now we need to connect this voltmeter. Okay, so just try to connect the voltmeter in parallel to the supply. So connect negative and directly connect to the rectifier type voltmeter, connect it to positive and connect to positive of the supply. Okay, so you may get doubt what kind of signal I have to apply. So here it is very simple. We have to have an signal generator is sinusoidal signal generator, and what is the precaution you have to take is just give the supply to the signal generator, then keep initially and frequency of 200. Before you give the signal, see that every reading you have to take by making the voltage as a 5 volts. Okay, so the peak to peak voltage is 5 volts. Just adjust this amplitude, then you can see here. So you are going to get an voltage of 5 volts. Okay, so every reading you have to take that the peak to peak voltage should be 5 volts, and we have been set the inductor to 100 ohm and the, sorry, I had set the resistance to 100 ohm, inductance to 50 millihenry and capacitance to 0.1 microfarad. Okay, so this is what given the circuit diagram. We have to cross check. Okay, I have to cross check and then start doing the experiment. So now let us try to go with 1000 hertz range, and let's try to keep the frequency as some 200. Here you can see here, now let's try to keep the frequency as 200. Okay, so now when you keep the frequency as 200, so slowly how to adjust, you should be a little bit patient while you are doing the experiment. So now approximately applied some 200 edges or 190, you can see here the current may increase. Now all these variations we should plot on an graph. So here we are going to have the voltage, how much we are going to set. There's nothing but 5 volts, and initially I had kept a frequency of 200, and the current which flows in the series RLC circuit, you can directly see from the meter, it flows approximately some 2 amperes. Okay. Now let's try to vary the frequency from 200 to 400. Let's try to go in terms of 200 range, 400. Let's try to go in terms of 200 range. So 400, approximately 400. So this is 400, and you have to set it the voltage every time to 5 volts. So if you set it to 5 volts, you can see here there is an increment of current, and it has obtained a current of 5 milliamperes. Just write down the given current. So for an voltage of 5 volts and the frequency of 420 or 400, then you are going to get a current of 5 milliamperes. And then the next one, let's try to go with 600 hedges. Okay, so just like multiple readings you can take whatever you feel convenient. So just I am cross checking with 600, so 577, or you can go with 600. Now it is 600, and peak to peak voltage you have to set it as exactly again 5. This is very important. Every reading you have to take care that this should be an 5 volts, and you can see here again current has been increased, and current has reached a current of 8 amperes. Like that you can vary the voltage step by step as 1 kilo. I mean, you can go with 10 kilohertz, and you can see here. So just to see the variation here. So now I am trying to move from 1000 hertz to 10k. Then you can see here current increases and it reaches resonance, and the current is maximum. Now you can see the frequency here. So here I am having approximately some 800. So around now it is 1.4 kilo, I mean 1400 hertz, and you can see here now current is maximum, and every reading you have to see that the signal should be of 5 volts. Okay, so you can keep 5 volts, or you can go up to 3 volts also. So it depends upon the range of the signal generator. Actually if I keep 5, it is not accepting beyond 5, that's why I am reducing to 3 volts. You have to continue with the same voltage. And now you are going to get the maximum. So now it is 1.4, and slowly you try start increasing. So now it is 1.4. So you should be patient in while adjusting the knob, because it gives a lot of variation. So now it is 1.600 hertz, 1.7 sorry 1.500 hertz. Now still the current is maximum. So like that we can see here I am keeping frequency of 1600, and once again current is maximum. So like that 2000. So at 2300, you see here at 2300 the resonance will occur. Okay, until 2300. So slowly and patiently how to adjust. So it is 2000. Now it is the exact, this is the resonating frequency. The resonating frequency is 2200 hertz, and you can see here the current is maximum. So the maximum current I am going to get the resonance when XL is equal to XC. So when you plot it on an tabular column, then you are going to get the maximum current as per shown in the figure is approximately 20 milliamperes at a resonating frequency. You can see here the resonating frequency occurring at 2200 hertz frequency, then automatically you get the maximum current. Now this is the original answer what we require, and again what you have to do is further you increase the frequency, then automatically current will decrease. You can observe that modification through the meter. So now increase the frequency. So as soon as you increase the frequency with the 2800 hertz, 3000 hertz, and you can see here amplitude also will increase, then you have to decrease it to 5. Okay, it's like taking the experiment for longer than 20 to 30 minutes. So now it is 3.4 kilohertz, automatically the current is decreasing. Now again I am going with 3500 hertz, automatically the current is decreasing. So similarly you try to increase the frequency. Now 4200 hertz, you can see here the current drastically decreases. This is what the modification you can see here. So if they vary the frequency from 1 kilohertz, so now I am trying to come in reverse. Okay, so when I keep in 1000 hertz, it is minimum, and still the frequency is 1000, and it is 2000 and 2000 to 100. So now after reaching that 2200 hertz, it is coming back. Okay, so after resonating frequency, the current will decrease and the meter will come back. This is what you have to observe very carefully while drawing. Now the frequency is 5700, automatically the current drawn also will decrease. Then if you plot all these variations in an graph, then you are going to get the graph like this. So up to 2000, this is nothing but the resonating frequency. At resonating frequency, we will be getting the maximum current. So as already shown, slowly the current will increase and it reaches the maximum current of around 20 milliamperes, and after resonating frequency the current will try to decrease. This variation you have to plot, and from this graph for this 20 milliamperes by root 2 if you perform, then you are going to get the RMS value. It will cut the graph at 2 points, draw the points vertically, then you will get lower cutoff frequency, draw the line to the bottom, then you are going to get upper cutoff frequency, f2 minus f1, then you are going to get the bandwidth. Okay, so this is what the procedure behind how to vary the frequency and how to obtain the resonance of an given circuit. Hope you are able to understand the concept of resonance. So the theoretical calculation will be in the card, and you can watch from the card, and the remaining experiments also will be available in the channel. We can see the things very clearly. Thank you for watching. We'll meet in the another video.